Hey, good morning, ladies. Good morning, good morning. Hey, come on in. Put your name in the chat, fill out that form. We're going to do our lab today. Who else is that? Good morning, Mr. Moore. Come on in. Put your name in the chat. We're going to get started on our lab today. Good morning, good morning, good morning. I did not have enough coffee this morning. It's going to be all right. How was first hour, guys? Anybody? Was it that bad?
It was okay. We just watched the movie.
Ooh, so y'all sleepy now.
I've been sleepy.
I'm,
First hour never there.
who was that? Who was your first hour, Mr. Moore?
Um,
Don't even know.
Probably speaking, we had Miss, I think her name is Thompson, but they switched. It was a new teacher.
Yeah. Well, we're getting there. We're getting there. So listen, this is a big day for us. So I need y'all to be woke, like rest to go, rest to do this thing. Um, we're gonna do a lab the first part of the day, and then we're gonna take a break, and then we're gonna take just a couple of notes so that we can even understand our lab even more. Now I'm looking forward to doing it with this class because you are the best class I have. I ain't lying. I'm just telling y'all, don't tell anybody else though, okay? Don't tell the rest of them. So I have like two people and I've emailed them. I've done all I can do. There are like two or three more people that need to be in this classroom with us. And I'm just trying to understand why they wouldn't be here. Do I need to give them a special invitation? I don't know. When they come, y'all be nice. Here comes Miss Thomas. All righty. Good morning, Miss Thomas. How are you? Good morning. You good? Come on in. Put your name in the chat. It's an exciting day for us. We're getting ready to do our lab. We got um we got some stuff to do. All right. And fill out that attendance link, guys. That's really the only way I can know for sure that you guys are here. My first hour is starting to get really sneaky. So I need you to fill it out for me. And I have to figure out how to get around all that sneakiness that they're trying with me. Good morning, Miss Wilson. Did I say good morning to you earlier? Yes, good. Don't want to forget you. All right. I'm not gonna wait because they'll just have to play catch up when they get here. It's not fair for us. We're here, we're ready to go. There is no due now, but there will be an exit ticket at the end. So you kind of want to stick around to the end and make sure you pay attention because it's going to be about what we're talking about. It's going to be about our lab. So let's get at it. If you guys unmute and tell me I'm ready. Be like SpongeBob. I'm ready. I'm ready. I'm ready. Right? Thank you. Are we the rest of us ready? Thank you. All right. And Miss Thomas, are you ready? I don't want to leave you behind. It's going to be one of them kind of classes. We all going to be working together. You good? I'm ready. All right. I'm ready too. Here we go. All right. So let's get started today. Like I said, we're going to be doing our lab. Let's back it up. I spent time on my picture this weekend, guys. What you think about my picture?
It's nice.
So I had to change it up since we're doing the lab. Beautiful, thank you. So today we are working on the naked egg lab. All right. So what are the key ideas that we're going to do? There's only two that we're going to do today. We're going to look at this question when we do our lab. How can an egg be used to prove osmosis and diffusion have occurred? How can an egg be used to prove osmosis and diffusion have occurred? That's the question we're going to answer with our lab. And it's going to be over a course of a couple of days. So we'll get that question answered sooner or later. The second question that you will be able to answer by the end of today is what determines the direction in which passive transport occurs? So we're going to be talking about passive transport. I just want to remind you, remember we've been talking about that cell membrane and how things go through that cell membrane. And we're going to learn today about passive transport, and we're going to learn about the direction of passive transport. So when you leave, you'll be able to tell me what direction is passive transport going to occur in. All right, how are we going to do this? This is the agenda. We're going to start off with part one of our lab. Did anybody get a chance to look at the lab report, just briefly kind of glance through it yet? Anybody? I didn't put it up to the lab report. No. I put it up last night. Normally I will put it up if we have a lab on Monday, which I like to do labs on Monday, start them on Monday. Then I will put it up Friday. And it's a good idea to kind of glance through it so you have an idea of what we're going to do on Monday. So it's okay if you didn't, because of course I'm going to go through it with you. I'm not going to just throw you in there like they did me. I'm not going to do you like that. All right. So we're going to start off with part one of the lab. And this lab does last for about a couple of days, 3 or 4 days. So we're going to be going through it one day, and every day we'll do a little bit at a time. Doesn't take but about 5 or 6 minutes, maybe 10 minutes at the most to do what you need to do for the lab every day. So part one we'll start with, and we'll talk about the purpose. We'll talk about the background information. This is all in the lab report. We'll do the procedure, and then we'll actually go ahead and do the lab and write our first hypothesis. Then I'm going to go over part two. Part two is what you are going to do tomorrow. So if you got something to do today for your lab, and then even though you won't see me tomorrow, you have something to do tomorrow for your lab. You have something today and something tomorrow. And I'm going to show you both days so that you can just get up and go to the kitchen or whatever and do your lab today and tomorrow. So we'll look at the procedure for what you got to do tomorrow. And then we'll take a little break and we'll come back and take some notes so that we have information to help us with the lab. So we'll talk about that passive transport, that stuff coming across the membrane. How does it get across the membrane? What direction does it go in? Okay, and when we talk about passive transport, that really should be A and B. We're going to talk about diffusion, and there's 2 types of diffusions, a simple diffusion and facilitated diffusion. Guys, just give me 1 second. I can't stand it when my when this doesn't go right, when it doesn't look right to me. I just want to fix something. So we're going to talk about passive transport. We're going to talk about diffusion. Diffusion. Oops, and it's all capitals. Just give me a minute. I just like to have it right. Diffusion. And when we talk about diffusion, there's facilitated diffusion and there's passive diffusion. Hold on. Simple diffusion and facilitated diffusion. That's what I want to talk about. Hold on. I know. Just want to make it right. Simple diffusion, facilitated diffusion, diffusion. And with facilitated diffusion, there are 2 types of channels. There's those. Okay. Promise. It makes I work better when my outline is correct. Let me just make this fit. Thank you guys for being patient. Whew. That was gonna bother me all day if I didn't change it. All right, so again, we're gonna start with part 1. We'll go through all the stuff in the lab. Then we'll do part 2 together and we'll take a break. And then we're gonna talk about passive transport. We'll talk about diffusion. That has simple diffusion and facilitated diffusion. And facilitated diffusion has 2 things, channel proteins and carrier proteins. Now, honestly, we may not get to those channel proteins and carrier proteins because I know first hour we ran out of time. I may have to move that to tomorrow. All right, anyway, let's get started with the lab. Here we go. So anytime you do a lab, like I said, I'm gonna usually give it to you at least a couple days ahead of time so you can read through it. The first thing that's on the lab is the purpose. Now that purpose answers a couple of questions. It answers the question, what is the experiment about? And then it answers the question, what are you going to discover? Or what are you trying to discover? Those 2 questions are answered in your lab purpose. Now for this lab, normally I have you guys come up with the purpose, but I'm going to give you the purpose. The purpose is given to you. So I want you to write this down. And as a matter of fact, you should have some kind of notebook to keep some little notes on so you'll kind of know what to do as you do the lab yourself. Watch me, take notes while you're watching me, and then you're gonna go do it. So write this down. This is gonna go in your lab report. How can an egg be used to prove osmosis and diffusion have occurred, right? Now, in your lab report, it goes, you're gonna write that purpose in your lab report. Now, let me show you what the lab report looks like. You click on here, and it'll take me right to that report. This is your lab report. And this is for the naked egg lab. If you give it a minute, there you go. Titles are gonna come across over here. Now, this is gonna be a good help if you need to figure out where things are. Let's say you gotta write hypothesis number 1. You could click on hypothesis number 1, and there it is. You just write inside of there. Let's say you have to write your purpose like you do right now. Click on purpose. And what I've done is the colored blocks just tell you what it is that you need to know about the purpose. And in the non-colored blocks, that's where you write. So what you're gonna do is you're gonna write your purpose in this white box right here. Who can tell me what the purpose is again? You're supposed to write it down. Write it down so I can say it out loud so I can type it in, show you how it's done. Anybody? I need to know, what is the purpose? Who wrote it down? Come on, guys. I'm waiting on you to tell me the purpose so I can type it in here. How? All right, tell me if I need to go back. Or just somebody just trying to find it out for me. Hey, wake up. I need y'all to talk to me. Told you this is not the class. We can't be quiet today. Thank you. The experiment is about a naked egg. Yes, but that's not what I'm asking. I'm asking, what is the purpose? On the slide, I told you what the purpose was and I said, write it down. Let's go back to the slide. Here's the slide. Sorry. And I said, there's 2 things that we learned about the purpose. And I said, it's what is the experiment about, what is it trying to discover, and this is your purpose. Normally, I don't give it to you, but I'm giving it to you. How can an egg be used to prove osmosis and diffusion have occurred? And I said, write this down because you gotta put this in your lab notes, in your lab report. And that's what I did. I clicked over to the lab report and I'm getting ready to write it down. Now, somebody, make sure you write this down. These notes won't be available to you. And if you don't have your purpose correctly written in your lab report, then you won't get those points for the purpose. Okay, so write that red stuff down. How can an egg be used to prove osmosis and diffusion have occurred? And then I'm going to head back over here to the lab and I'm going to write that. Somebody tell me, what did it say? How can, keep going. Practicing on my wait time. It's not going to go well for us, guys. I need somebody to answer me. How, what is the purpose? It's the easy part. Miss Thomas, what is the purpose? Are you there? Guys, hello, 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 hello. Are you there? Are you there? Are you there? Are you there? Thank you, Miss Smith. You can say it. How can an egg be used to prove osmosis and diffusion have occurred? Thank you, thank you, thank you. I was about to think I was all by myself. Now, guess what I'm going to do? Because I'm just that lazy. I'm going to cut and paste. Control C. Come over here. Control V. Done. You have just gotten all of your points for the purpose. Just like that. Okay, guys, I need you to pay attention. That's all you need to do for purpose. So that's the first part. You've done the first part of your lab. Now let's go back and see what we need to do next. Sorry, I keep running into that. All right. So did the purpose. Now let's move on to the next part. The background information. The background information is very important because it tells you a couple of things. It explains what you already know, and then it helps you, it helps you to find out what you don't know. So you always, always, always read the background information before you do the lab. Read the background information. So you write your purpose, you read your background information. Now, if you do that, if you read the background information, it'll help you when you're setting up your project or your experiment. It will help you to write a good hypothesis, and it'll help you to explain the results when you're done. If you read the background information, never, never, never skip the background information. All right, so we're gonna real quick look at the background information. We're gonna see that we know some things and some things we didn't know. So let's take a quick look at the background information. I need y'all to be reactive. I need you to commute, engage with me, engage with me. Here we go, background information. Here it is right here. The purple part, remember, is just the explanation. The stuff in the white is the actual background information. So it says, cells have an outer covering called the cell membrane. We knew that. Now, the membrane is selectively permeable. It has tiny pores or holes that allow objects to move across it. Okay, we knew some of that. We knew that it has pores and holes that move things across. We didn't know it was called selectively permeable, so we learned something new. The cell membrane controls what moves in and out of the cell. We knew that. The membrane is what is the doorkeeper, the gatekeeper. We knew that. Food and oxygen move into the cells across the cell membrane through a process of diffusion. Oh, we didn't know about diffusion. We knew that food and things moved across. We did not know it was called diffusion. Now we know. Well, what is diffusion? Diffusion is the movement of a substance from an area of high concentration to an area of low concentration. You're going to hear that a lot today. Diffusion is the movement of a substance from an area of high concentration to an area of low concentration. Okay, new information. Osmosis is a special type of diffusion. It is the diffusion of water across the selectively permeable membrane. Okay, that's new. Osmosis occurs when water moves from an area from where it is more concentrated to an area where it is less concentrated. Okay, so again, we read the information, we knew some stuff, we learned some stuff. We did it. Check that off the box. Move on. We did the purpose. We read the background information. Now what do you need to do? Now, let's look at the procedure. You never do an experiment without looking at the procedure first. And the procedure is simply a step-by-step instruction on how to do the experiment. And it looks a lot like a recipe. Always read the procedure first. So let's go to the procedure part and read through it, and then we're going to do this lab. All right. So what is the procedure part 1? Remember, we're doing part 1 right now. So we're going to let it load up. Come on, you can do it. And we're going to go down to part 1. Right here, procedure part 1. Making a naked egg. Oh, look at that. Let's read it. It says, gather the following materials: a raw egg, vinegar, and a jar, a container with a lid. Write your name and period on the pieces of masking tape and place it on the jar. You don't necessarily have to do that because you're at home doing it. We're not in the lab doing it. Number 3, and this is highlighted. It says, carefully measure the mass of the raw egg using the triple beam balance and record the mass on the chart beside day 1. You're not going to be able to do that. So it says, this was done for you in class. I'm going to do that for you, and you're going to mark it down. Okay? Now, look at the raw egg and write 2 observations about the egg on the chart next to day 1. Okay, we can do that. And then carefully place the egg in a beaker, pour vinegar in the beaker or whatever container you have until it just covers the egg. Now the egg is going to float. So part of the egg will not be in the vinegar. That's going to be okay. And then number 6 says, place the beaker on the counter, return the materials and supplies, and clean your work area. Done. Part 1 is done. So let's go ahead and do that. We read the procedure. We are ready to actually do this lab. Remember, right now, you are just going to watch me. Then you're going to do it. So get your notes out, take some notes on how I do this. And then you're only going to need your egg, your vinegar, and your container today. All right, so let's go ahead and I'm going to stop sharing and show you what we're looking at. All right, this is our lab. Now, no one came in and got any, well, no, a couple people said they're coming in, but there are still kits available if you don't have this stuff at your house. If you do got it, then you don't need to come get the kit. You can do it at home. All right, so this was the kit. And these are the things that came in the kit. You got acetic acid, which is vinegar. You got distilled water, and you got corn syrup, and you got distilled water. The only thing you're going to need is the vinegar today. So you don't even need to take those out right now. And you're going to need an egg. So I have the egg here. First thing they said to do was to weigh the egg. So I'm going to put my scale out. You guys can see that. And here's my egg. Now, because you can't weigh it, you're going to have to write this number down, right? We're all going to use this same number. So I'm put my egg on the scale. Wait, let me cut it on. Here we go. Hello. Hello. Okay. Put my egg on the scale. All right, I need somebody to write this number down because you're going to need this for your lab. All right. And the number is 1.94 ounces. 1.94 ounces. I hope you're writing that down like you wrote that purpose down. 1.94 ounces. Everybody got it? I should change it to 5, but we're going to leave it like that because it does round up. 1.94. Okay. Now, it said to look at your egg, think 1.94 ounces, correct, OZ, ounces. It said to look at your egg and tell me give me 2 observations. Now remember, observations are what we use our senses for. So my egg it's kind of cold. The shell is white. It's a little wet because I had put it in something. I don't see any cracks or anything in the egg. So I'm going to write down 2 observations. First observation that my egg is cold. And it's a white, the shell is white, it doesn't look cracked. Cold, white shell, not cracked. Now your egg might be something different. I'm just showing you what to do. All right, so after I've done that, then I'm going to open up, I'm going to get my container with my acetic acid or my vinegar in it, and I'm going to carefully take my egg and put it into my acetic acid. Now I have way too much and I don't need that much. But once I've done that, I'm just gonna put a little top over it. You don't have to. And then I'm gonna put that to the side and I'm gonna clean my work area. So let me grab my paper towel, clean up my mess, and put all my things away. Put my eggs back in the refrigerator so your mom's not gonna get mad. Put all my stuff away. I'm almost done with day 1. So now what do I do, Miss Gresham? All right. Now you're ready to go to your lab report and write all this stuff down. So I'm going to share my screen again. There we go. And hold on. Let me get my chat back up so I can see it. There we go. And I'm going to go back to the lab. Hold on, let me go backwards because I don't want to show you that part. I should put that on there somewhere. Okay, I'm going to go to the lab where the procedures were. It doesn't matter. Get to your lab. So I've written my purpose in. Now I need to write down this information that I just jotted down. So I'm going to go to, scroll down to where it says mass of egg, my data collection, right here. Oh, look at that. Mass of the egg and my observation are going to go right there. Now I made this, highlighted it or filled it in with yellow because that's the part that I did. So you have to remember what was done in class. Somebody tell me what was the mass of the egg, because that's what's going to be in your on your data, on your report. What's the mass of the egg, Miss Wilson? You have it written down. What was it? $1.94. And you gotta tell me the ounces. You can either put OZ or that's the same thing as OUNCES, ounces. All right, now, then you're gonna come over here and you're gonna write 2 observations. My first one, and your observation is not gonna be the same as mine because you got a different egg. The only thing that's gonna be the same as mine is the mass because you guys don't have the capacity to weigh it, but we can. So my first observation is the egg was cold to the touch. And my second observation was the shell was white and uncracked. No cracks and no cracks observed. And no cracks observed. Okay, I'm done with that part. I'm doing good. I only have one more thing to do. Any questions so far? Because that's what you're doing today. You got one more thing to do today and you're done. Go back here. So we did the procedure. We just did the lab. And now we need to write our hypothesis. Right. You're going to do day one hypothesis. Correct. Now, remember, when we create a hypothesis, it's a prediction statement for this. So it's an educated guess based on what you already know. And this is always going to be specific and exact. And because we are testing a hypothesis, it's going to prove whether it is true or not. Our experiment will prove it. Remember, when we write a prediction, it's got to be if-then statements. So let's go ahead and go to the hypothesis number one and write our hypothesis out. Okay, so I'm gonna let it load again. Takes a minute. Here we go, here we go. There it is. Oh, and look at it, hypothesis day one. Here we go. And it asks, predict how the egg will respond when left in vinegar for 24 hours. Somebody in the chat or out loud, I don't care how you do it, what do you think is going to happen after 24 hours sitting in that vinegar? Just, there's, based on what you know, what do you think is going to happen? The egg will be bouncy. So let's be a little more, so if I put the egg in vinegar for 24 hours, then when I take it, out, oh, you did the project before. Ah, that's okay, it's okay. The egg will be bouncy. So that's what you write. You would write, if I left the egg in vinegar for 24 hours, then, sorry, the egg will, be bouncy. Can you give me a little bit more? What explain what the shell is going to look like? That's what I'm concerned. You said bouncy. What does that mean exactly? Tell me about that's one. Give me some more description. It'll be bouncy. What else, Miss Wilson? The shell is going to fall off. And what am I going to see, Miss Morgan? Okay. It's okay if you don't really know. That this is good enough. The egg will be bouncy. The shell will fall off. All this is good. Now, that is, I can't believe I did a small I. I always do capital I's. Okay. I feel a sneeze coming. There it is. All right. Another one. Okay. And I got two L's. I am not doing good right now. There we go. All right. If I left the egg in vinegar for 24 hours, the egg will be bouncy. The shell will fall off. Perfect, perfect prediction. Now, that doesn't have to be your prediction. You can do something. I think the shell will change its color. Okay, then you would write that too, if that's what you know. If I left the egg in vinegar for 24 hours, the egg will be bouncy. The shell will change its color. Yeah, the color will probably change. You can write that. You don't want to say probably, just say the color will change. It just don't sit on the fence. Take a stand, okay? And it's okay if you're right or you're wrong. You just need to have an idea at the beginning of what you might expect. Okay? So once you have written your hypothesis for day one, guess what? Day one is done, completed. All right? So what I'm going to do is walk you through day two, because day one is for Monday. Guess what happens Tuesday? And I know you're not going to see me Tuesday, but Tuesday, you're going to do day two. So I'm going to walk you through day two. I have an egg that I have already let sit for 24 hours, and we're going to take a look at it and see what it looks like. You might even be able to get a better idea. All right, so let's take a look at day two. Remember, before you do anything, you always want to read the procedure first before you start doing anything. So let's look at procedure two. Procedure two, tomorrow is when you're going to do this. Here we go. Let's read it. So we click on our report and we go down here. We'll wait for it to load. And we're going to go down here to procedure day part 2, exposing the cell membrane. Let's read through it real quick. It says, pour off the vinegar down the drain. Catch the egg in your hand. Be careful, the egg will be fragile. So we're going to have to pour the vinegar off and catch the egg. Move the egg to a paper towel and pat it dry. Measure the mass. Uh-oh. Remember, that was a part that Miss Gresham has to do for you. Now I'm going to do that today for you. Measure the mass of the egg, record the mass, look at the egg, and write 2 observations that you noticed about the egg on the chart. And then place the egg back in the beaker and pour vinegar in the beaker until it covers the egg. So you might have to have a little more vinegar if you get a box from me, or save that vinegar. And then place the beaker on the counter, put your materials away, clean your work area. All right, let's try it. This is 3rd hour. I have an egg that's been sitting since yesterday for 24 hours for you. It's got 3rd hour on it. Let's take a look and see. Let's first see what it looks like. This is 3rd hour's egg that's been sitting for 24 hours. This is 3rd hour. Okay. Ooh, let's look inside. Can you see it? Okay, I'm going to take it to the sink, and I'm going to take you to the sink with me. And we're going to rinse it off. And we are going to pat it dry on some paper towel. Remember, you got to be very gentle with this. What do you think will happen if I'm not gentle? Anybody? Mr. Moore, what's going to happen if I am not gentle with this egg?
It could break.
Yeah, you're going to have a busted egg on your hand. We don't want that. Okay, guys, I don't have a cameraman, so you got to just be patient with me. That's my sink in my classroom. Can you see the sink? Yeah. Okay, that's my vinegar bottle over there. I'm trying to get this so it stays. It's not cooperating well. There we go. Okay. All right. So now, let me see if I can see you guys. All right. So here is my egg. I'm going to carefully pour it into my hand. Look at that. All right. I got to be very gentle with it. I'm feeling it, and I'm going to pour a little bit of water over it to just kind of rinse it. I'm going to carefully pour it, gently pour some water over it and rub, gently. Gently pour the water over it and rub. Very gentle. Can you see? Okay. All right, and I'm just gonna do that a little bit. That's what it looks like after 24 hours. Now I'm gonna cut the water off. I'm gonna put this on a, sorry, I don't mean for y'all to get dizzy. There we go. Put it on, nice paper towel. Rinse off my top. Okay, and now it says I need to weigh it. Now, because you can't weigh it, I'm gonna weigh this egg for you. This is gonna be our 3rd hour egg. I'm gonna weigh it for you. But you're gonna use your observations, not mine. So here we go again. Here we go. And stop sharing. There we go. So now, cut it on. And I'm gonna put the egg carefully because it is very fragile at this point. And now I'm gonna weigh it. I need you to write this number down because guess what? You gotta put that number in your lab report. Your number is 2.12 ounces. 2.12 ounces. Everybody should have written that down. Then you're gonna take your egg, carefully put it back into the container. There we go. And it said to just pour the vinegar on top, just carefully, because we do not want to break our egg. We won't have vinegar egg. Pour the vinegar just so it covers it almost to the top. And we'll put my top back on. Set this away on the counter and clean my work area. Do not leave a mess for your parents and then I have to hear about how messy you guys left it. Clean your work area. Okay. And that's it for day 2. That's all you're doing for, well, wait a minute. We got to go into the lab here. Let's go to the lab report and write this down. So I'm sharing my screen again. And now we're in the lab report. And we want to go to data, mass of the egg. All right, somebody remind me, what was the mass? What is the new mass of our egg after day 1, after 24 hours? What is the mass of the egg? 2.12, right. Oh, sorry. You want me to stop sharing?
No, that was when you was doing the
Oh,
egg thing.
sorry. Did you want to see something that I didn't show you?
No.
Okay, so I'm gonna put 2.12 ounces either way. And then you tomorrow are going to write your observations because your egg will have been in the vinegar for 24 hours. You're gonna take it out, rinse it off, look at it, and you're gonna give me 2 observations. 1, and then you're gonna give me 2. Your observations on your egg. Okay. And then you're ready for Wednesday. Once you guys have done that, you'll come back and I will direct you on what to do for Wednesday. All right, questions, comments, concerns, anything that I left out or that is not clear at all to you, now would be the time. Anybody? Okay, so do you think you'll need it done? Does anybody need a kit? Because there are a few available at the at the doorway when you come in the high school lab, high school um, door. Okay, I need a yes, no, or maybe. Work with me, guys. Everybody good? Yes or no? Mm, mm, mm. I thought y'all was gonna be my bomb plan. Thank you, Miss Morgan. Okay, all right. So let me see. That's all I have for our lab. It is 10:24. We're still good on time. So we're gonna take a break, a 10-minute break. You could go check in your check to make sure you have all the stuff that you need. And we're gonna take a break. When we come back, we're gonna take a couple of notes. Not a lot of notes, just a couple of notes, but you need your notebook. So I will see you in 9 minutes and 45 seconds. Go. All right. Third hour. We got about 2 more minutes. You all should start coming back. Oh, 57 seconds. I'm sorry. I'm busy doing something. Come on, let's get back. Okay. Condolences. Mhm. Okay, guys. Mhm. Mhm. Okay, guys. I started a text. I had to finish it. I apologize. I'm back. Are you back? 18 seconds. I'm back. Are you back? Hello. Oh, good. Good, good, good. Miracle's here. Malaya's here. I ain't heard from Mr. Ricky Moore since the beginning of the day. And who else? Miss Thomas, are you here? Are you back? Hello, hello, hello. Hello. Thank you, Miss Thomas. Now, Mr. Moore, are you here? All the ladies are here. Where's
Yeah.
the oh, wonderful. All right, guys, hang in there. We're just about done. All we're gonna do is take a couple of notes today. It's not a lot. I need you to stay with me. Stay with me. Don't get lost. Stay with me. All of this is gonna make sense soon. Okay, here we go. Remember a couple of weeks ago when I did an observation or just a demonstration, and I put a drop of food coloring into a glass or a beaker of water, and we watched it disperse into the glass until the whole glass was blue. We talked about, we kind of looked at that, and today we did just like he did, and we watched it till the whole thing got blue. Today we're going to talk a little bit more about that same thing, and we're going to relate that to, that is passive transport called diffusion. Diffusion, that's what we're looking at. Diffusion at its best right there. And look at this. We can see it done even with hot water, cold water. Of course, hot water is going to diffuse more. It's going to go from a high concentration to a low concentration. It's going to start off real concentrated, that piece of dye, that dye, and it's going to start spreading out, moving and moving it till it fills up the entire cup. So we say that in a solution, randomly moving molecules tend to fill up a space. Molecules don't just stay in one place. They don't just stay concentrated. They start to spread out and fill up the space. And when the space is filled up evenly, when that whole beaker is blue, we call that state equilibrium. We say equilibrium has been reached. And here comes, all right, come on in. We missed you, Miss Wallace. You missed the lab. We're all done with the lab.
Yeah, I fell asleep.
Oh my goodness, please get with your friends so that you can, you know, do the first 2 days, because that lab is very important. It's 40% of your grade, but they can help you. They're good. They got it all. They got all the information, and they'll help you. Right, guys? Right, guys? Oh, Lordy. Of course they will. Talk nice to them. Thank you. Thank you. All right, I'm putting the link in the chat for you, Miss Wallace, and we're taking notes. This is the second part. We already did our break. We're taking our notes. Okay, so when that cup filled up with all blue, we call that equilibrium. The molecules reached a point that we call equilibrium. All right, let's keep going. So far, we haven't even had to write, y'all. Good. Now, get ready to write. The amount of a particle substance in a given volume is called the concentration of the substance. So if I'm talking about a concentration, that's telling me how much volume is being taken up of that thing, right? So if I have if I'm making punch, and you know, sometimes we make punch from this stuff we call concentrated, right? It's really thick, it's really sweet, but that's very concentrated because it's all, most of the sugar stuck together. It's not spread out in the water, right? So we have concentrations. Most things, when one area has a high concentration than another area, let's look at that blue food coloring again. The food coloring is highly concentrated, and it starts out as high concentrated. When it goes from high concentration to low concentration, what it does is when one area has a higher concentration than another, we say we have what we call a concentration gradient. When one area is higher than another area, we call that a concentration gradient. So if we think about that blue food coloring again, it started out like this. It was all the blue was in one area. It was a high concentration here and a low concentration down here. We call this, when we have one side higher than the other side, we call that a concentration gradient. That means we can gradually see how it goes high. It's a lot here, and eventually as we get to the bottom, there is a little bit. Write that second bullet point down. It says, when one area has a high concentration, a higher concentration than another area does, a concentration gradient exists. When one area has a higher concentration than another area does, a concentration gradient exists. That's what happened with that food coloring. We started out with a whole big old blob at the top of the water. One area had more blue than the other area. We had a concentration gradient at that point. Now, eventually that concentration gradient, all these molecules start to move and they get to be equilibrium. But before they were in equilibrium, we had a concentration gradient. We can see that we had a lot more here and less down here. That's called a concentration gradient. Okay, so you've written that down. Let's keep going. Now, when we talk about concentration gradients, we can talk about something called diffusion. Now, what is diffusion? Diffusion is the movement of a substance down that concentration gradient. So as it moves from high, and those molecules keep going and move on down the concentration gradient, they are diffusing. That's what that's called, diffusion. Diffusion is when molecules start out really high. Let's look at it again. Diffusion. I want you to think of that drop of food coloring. that food coloring in the water starts out here, and then eventually it spreads or diffuses across the concentration gradient. It moves down that concentration gradient. It begins to fill up that whole container, that whole beaker ended up blue, if you remember, when you recall when we did that. Okay, so write that down. The movement of a substance down a concentration gradient is called diffusion. That's what we call it. When it goes from high concentration and moves down that concentration gradient to or towards the low end, we call that diffusion. Okay, we're doing good. Let's keep going. Tell me if I'm going too fast. All right, I'm gonna need you to write now. First, I want you to listen. We know some things already because we're gonna relate this to the cell membrane. We know that the cell membrane separates the cytoplasm from the fluid outside the cell. Inside the cell, we have the cytoplasm. Outside the cell, we have some fluid outside the cell. Well, we talked about that. We've been talking about that. We know that. We also know that some substances enter the cell and leave the cell by diffusing across the cell membrane. Maybe we didn't know that. The way some things go from one side to the other, they use that concept of diffusion. They diffuse across that membrane. Write that down. Some substances enter and leave the cell by diffusing across the cell membrane, going from a high concentration and moves right on down that gradient to a low concentration. We'll see that real soon. Just write it down. What else? Write this down. Now, the direction that it moves, like, remember we said it might start up here as a high concentration and then it moves towards that, down that concentration gradient. The direction depends on the concentration gradient. And the direction does not require any energy. This happens passively, all by itself, without any help. I don't need any ATP. The cell membrane just knows to do that. It lets stuff go from high concentration to low. It will always go from high concentration to a low concentration. All right, so I hope you got those two written down. And let's look at this last bullet point, which you don't have to write down. We remember that some substances diffuse through the lipid bilayer. Some things are small enough that they can diffuse. Remember, those non-polar small molecules can go through that cell membrane, that lipid bilayer. But others aren't able, they're too big. So they can go through, but they go through those transport proteins. Remember, we talked about those just the other day. So some of them go through those phospholipids, and some of them go through those transport proteins. But they all diffuse, which means they go from a high concentration towards the low concentration. Wherever there is a lot of it, it's going to start moving to where there's a little bit of it. It moves across the concentration gradient. So let's take a quick look and listen to this young man or old man who's going to tell us a little bit about this cell membrane and how things are moving. He's going to say the same thing I said, but it may be a little better way for you to understand, especially with the pictures. Okay, let's listen. Oops, go back. I don't want you to hear him yet. I want you to hear this guy.
Diffusion can also occur through cell membranes. However, cell membranes are selectively permeable. This means that some substances can diffuse through a cell membrane while others cannot. The flow of ions or molecules through a cell membrane as a result of diffusion is referred to as passive transport. It is referred to as passive transport, as it requires no energy from the cell in order to carry a substance across the membrane. In the process of passive transport, the membrane acts as a filter. Phospholipids and protein channels control which molecules can cross the membrane and may influence the rate and timing of the movement of ions and molecules across the membrane. But they do not influence the direction of movement. Substances continue to move only from areas of high concentration to areas of low concentration. Let's now.
Okay, like he said, it doesn't control, it can control what goes through, but it won't change the direction. It will always go from high concentration to low concentration, very similar to that blob of food coloring, that blue food coloring that we dropped into that beaker, and we saw it all concentrated together. That was high concentration. And after a few minutes, it moved. It moved from high concentration and started moving out and spreading out to low concentration. And after a few more minutes, it reached equilibrium where that blue was all through the whole beaker. That's what diffusion is. And this same thing happens in a cell through the cell membrane. That cell membrane allows things to go through, and it will from high concentration to a low concentration. So remember, some things are too small, are too big. So it can't go past that phospholipid layer. The bigger things have to use a transport protein. That's why we talked about proteins all last week. That transport protein will help to carry it through that bilayer, but it will still go always from a high concentration to a low concentration. It always moves in that direction. That's diffusion. Now, there are two types of diffusions, like he said. One type of diffusion is going to go right through those phospholipids without any problem because they're small and non-polar. But there are other things that need to get through that are not small and that are not non-polar. They are going to use those transport proteins. So we have a simple diffusion, which just goes through those phospholipids. And then we have facilitated diffusion, which means it has to go through the transport protein. Let's just take a quick look at both of those, and then we're done. We're going to watch a quick video, so you don't have to write anymore, that talks about simple diffusion that just goes through that cell membrane, and then facilitated diffusion that goes through the transport protein, okay? Simple diffusion and facilitated diffusion. Okay, let's just take a look. Let's look at simple diffusion first.
Let's start by looking at simple diffusion. So here's my phospholipid bilayer, and here are some small uncharged molecules, possibly oxygen. Maybe not, but possibly oxygen. Now, simple diffusion is dead straightforward. It's movement from a high concentration to a low concentration. There we go. The particles have moved from where there was lots of them to where there weren't very many of them. It's dead straightforward. So here are the key characteristics. It involves movement from a high concentration to a low concentration. We don't need a carrier protein. We don't need any external energy. It happens passively, and it usually occurs in very small or lipid-soluble molecules. So a very small molecule might be a gas like oxygen, and a lipid-soluble molecule might be something like a steroid. Moving on, we'll look at...
We're not going to move on yet. Okay, so just back up just a little bit. I want to make sure we got this. We said that it goes from high concentration to low. This is simple diffusion. Now, if we pause this, I thought he could pause. I guess he can't. Right here. Simple diffusion. Back it up. So picky. If we look at this, it's got a lot of molecules at the top and only a few at the bottom. So remember, we said it always goes from high to low. And simple diffusion is just going to go through those phospholipids like that. Went through the phospholipids, no problem. Now, that's simple diffusion. And again, he said it goes from high to low. There are no carrier proteins, no transfer proteins. It doesn't cost you any energy, and it's always going to be small non-polar particles that are able to do that. That is, I'm sorry, that's not facilitated. That is simple diffusion. Now let's look at facilitated diffusion. Let's take a quick look. I'm going to let it play and then I'll talk about it. Hopefully I didn't cut the sound off. I did. Hold on. Hold on. Let me get the sound back. It's
And here we see
okay,
that
back
these
up,
larger
back up. Here we go.
biology video about membranes and transport. This video is going to be about transport
Go
across
back
the membrane.
this way. Go this way. And play. Thank you.
Diffusion. Now, facilitated diffusion has much in common with simple diffusion, except it requires these things called carrier proteins. And here we see that these larger molecules move through the carrier proteins. Still, we're moving from high concentration to low concentration, but the only difference is that these carrier proteins are required to allow these large or charged molecules to pass across the membrane.
That's it. That's the only difference.
So some key features here. Again, high concentration to low concentration. This time we need a carrier protein, no energy required. And this is used to transport large, like glucose, or charged, like ions, across the cell membrane.
Okay.
Finally,
all right, nope, that's all we're gonna do. So again, facilitated diffusion just is for those bigger molecules that can't get through the phospholipid. They use those transport proteins, and he called them carrier proteins. We're gonna give them names in a minute. They use that to get through that membrane and past those tails that won't let them get past on their own. All right. Okay, guys, any questions, comments, or concerns about today? We did a lot. We did our lab. You got your instructions for today, what you got to do for your lab, and tomorrow, what you got to do for your lab. And make sure you fill out the lab report. Thank you, Ms. Wilson, no question. All right, so I'm going to show you the, real quick, let me get out of here. Go to our classroom. This is third hour. I'm going to show you the exit ticket. There are 3 questions in the exit ticket that I need you to answer. Uh-oh, it's a little early because I told it not to, let me get it started. I said 10:55. I'm almost on time. Let me edit. And I want to go ahead and schedule it or assign it. Get rid of that and assign it. Yep. It's assigned. Okay, it is now posted at the top of our classwork page. You want to go in and fill out this exit ticket. That's for the naked egg lab reflections. So I got a couple questions about the lab that I want you to answer, and then I want you to go on. When you're done with that, then you can just put done in the chat. And that's all I got for you today. You can go on ahead and start trying to get your stuff together for your lab. You got 2 days of lab to do. You got to do something today and something tomorrow. And then Wednesday when we get back, we'll see what we got. Questions, comments, concerns? Everybody know what they're supposed to be doing? No? Or you said no questions, no comments, no concerns? You got it, Miracle. Ajane, you okay? Okay. All right. So go ahead, do the exit ticket. And when you're done, just put done in the chat and I will dismiss you. I'm going to take a snapshot of our lab. I have to stop sharing to do that. All right. So don't forget to put done in the lab when you're done. Let me give a snapshot of this. Thank you. Okay. This is for third hour biology. This is for day 1. Observation. Okay, Miss Morgan, bye. What is LOL for? Did you want our middle? No, no, just your first and last name is good. Thank you. All right, y'all. Make sure you do that lab. Okay, Miracle. Okay, Mr. Moore. Miss Wilson. Hi. You okay, Miss Thomas? All right. Okay. 2 hours. Let me see if I can. I can't be. Why is it? I'm too. I can't be. I just paid them. This is not making any sense. I thought I said I scheduled a payment. Why the heck are you bothering me? I'm not too behind on everything. I can't be. This is bugging me. Payment's not. Okay. I need to figure out how I'm going to dun, 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 dun.